So today we're going to practice making a scatter plot of some data that might not necessarily be a linear fit. Most of the data we've looked at up until now has been a linear fit. So we're going to be looking at some angle versus acceleration data from a lab. So we'll be plotting some various angles and some acceleration. So let's say that we measured them and we found out that the angles were close to like 5, 10, 15, just kind of going up degrees. And we do that click and drag to about 25. And we find our data is about, well, a 4.15, a 3.32, we'll say, a 2.55, a 1.70 exactly, and the last data point was a 0.80. Okay, so with these data points, we're going to take and make these things a little bigger for a second just so you can see them. Okay, there we go. So you can see it a little easier, the data I've got in. So we've got these angles, they're in degrees. We've got these accelerations, they're in meters per second squared. So I would have recorded them from a lab. And I'm going to highlight them. And we're going to make a chart. So the other way to insert the chart is over here instead of going into the insert column. And give it a second. Chart editor comes up. Type of chart we are looking for, though, is a scatter. And you'll see they do kind of look linear, this increase it looks like, but it could just be an artifact of the scaling. So we're going to put on customize. Our chart style has already been kind of chosen there. Our chart axes. So the chart title will be angles, variation of acceleration with angular, or with change in angle. And subtitle, as always, is our name, Mr. Magno. Horizontal axis is right now our angle in degrees. And our vertical is our acceleration in meters per second squared. Okay. So we have our series that we know. Might make the points a little smaller. I do have some error here in my measurements. So we have a fixed value on each of these of 0.01 in all my measurements. So it's kind of hard to see, but it's constant 0.01. I don't need to see the data labels, but my trend line might not be linear. And I'll see the equation. So right now I got a linear on there, but if I show the R value, well, it looks like it's kind of shown as almost linear, 0.999. But what if I took it up to other polynomial even? So if we go polynomial, I can go order 2. And if I go order 2, it makes the R squared exactly 1, which shows it's a very, very good fit. So now I've got our legends. Okay, I like to keep my legend on the bottom. Again, you can kind of see that trend that's kind of forming there. And now we've got our axes. I don't generally like to let them just auto scale. I always want my horizontal to start at 0. And in this case, I'm going to try to get it so it goes all the way up towards a full angular deflection of at least 45, because that's halfway between 0 and 90. Okay? And then for that, that means on my vertical axes, we'll start the minimum at 0, and the maximum, we want to see a little higher, just so you can kind of see where the trend was going. So I'm going to go up to like 10, see if that's enough to see where it's going. It might be even a little more. that I need to go to. Let's say just to 8 in my case. So you can kind of see where the trend was going. And it kind of starts, you can see the curve a little better that way. Grid lines are fine the way they look. And I guess we can just kind of go over here and say we're done. And maximize it a bit. So as you can tell, our error bars are very, very small because we have some very accurate data. But looking at this, you can see the trend of, well, where would we expect it to be? It isn't necessarily going on a perfectly straight line as the change happened. Even though we were at a 0.999 on linear, by the time I got to a polynomial squared relationship, it got to be an r squared of 1 on this data.